Okay, onward.
Okay, so this is a pre-cordial to give people exercises and things to do to improve your cross-country skills at whatever level you are. And I tell you, giving that little Thermaline talk a while back and working on the curriculum, I didn't put it in practice, and I have gotten a whole lot better at Thermaline. I used to not be able to thermal equal to the Sean Fiddler and Eric Nelson and maybe Sarah, Carl, a couple of others, three or four others. And now I can. And in fact, at Perry, I was able to outclimb. Uh, we had very weak days at Perry, and I was able to outclimb a couple of 29s flown by top pilots, and they were 8.5 pounds, and I was at 10.5 pounds. So, yeah, so I'll share some of that, and some of that I've talked with Scott and Pat and Harley in preparing a sort of a coaching syllabus for us. So that's one topic. Is if you can't thermal really well and center really well, it's hard to go cross country. Second, we'll talk about how to read the weather the morning of the flight and create an ideal task. I am a believer that the task should only be set at 9:30 p.m. or later when you have the next you know sky sight iteration. And this is not for badge or records where you got to pre-plan triangles and do all that stuff. This is to learn how to go cross country. Remember that everything I'm going to talk about is skills development for cross country. So the task doesn't have to go to any turn points. It just has to go to the good air and later on come back from the good air. So all you're trying to do is say, I'm going to go in that direction. SkySight confirms it's the best. I'm going to align with the convergence or I'm going to align with the wind and then I'm going to come back. So it's all about developing skills. So we're going to talk about how to use SkySight the morning of the flight to give yourself a 20-mile little task. And by the way, I'm not a believer in fixed points for learning tasks. Give yourself an area. Say you're going to go to Madison plus or minus 10 miles. And then you go there, and it's like an area task. And if it's really good, you keep going, really going. When the clouds stop, you turn around and come back. So don't give yourself a point in the beginning when you're learning, because the learning starts with learning how to follow energy lines. Cross country is only two things: how to climb and how to follow energy lines. If you do the two, you can go. Okay, so those are the skills that need to be learned. We're not talking about learning process methodology, how to file flight plans or whatever. We're learning some pilot skills. Okay, so that's the goal today. Perhaps I would like to start with thermaling because that's been the most revelatory thing to me. And I'm going to share a particular uh, PowerPoint here. Okay. Can you all see?
Yep.
Yes, yes,
Okay. FS recent learnings.
right.
Um, as you heard me before, and now this has really been validated in my mind. Learning is experience, all else is just information. So a real seminal moment for me when I was doing my flight review with Scott, and he and I went on the 21, and I hadn't flown the 21 in eons, and I was very rusty. I probably hadn't flown any gliders in 6 months. My glider had been put away in September, and we were doing the flight review in preparation for my going to the seniors, as I recall. And I said, okay. But also, we had had a meeting in which the club pointed out that people aren't staying up and we're getting very short flights, therefore, there's no interest. So I said, well, people need to thermal better to stay longer. So Scott and I got on the 21, and he was just in the back seat reviewing me. And I said, okay, well, let me see how slow I can thermal this glider because intellectually I knew that the slower the better, the slower the better. Well, I turned and I said, I've really got to learn to thermal at 45 degrees. Not that normally I would do that, but the whole goal is to have such a good intuitive feel for the glider that you can handle it at one of the corners of its envelope. So I said, let's do 45, 40. I didn't say that to Scott. I said it to myself. So I put in a 45. It happened to be the 21 that has a triangle, so I knew exactly what 45 was. And I pulled the stick all the way into my crotch until it hit the stop and held it there so that there was no movement of the stick possible. I could only fly with rudder. And lo and behold, we were circling at 45, 40. I couldn't believe it. Scott, are you there?
I am.
Okay. I couldn't believe it. I said, oh my gosh, it was mushy, but it wasn't really stalling. Every once in a while, there would be a tendency for a wing to begin to drop, but all it took is opposite rudder. And I was balancing with rudder, minimal aileron movement, and we're able to climb. I said, oh my gosh, this is pretty transformational. If one can fly that slow and that tight, the thermaling radius is going to be like 180 feet. I mean, it's ridiculous. You're just going right next to the birds. Um, and we were climbing good. So I started then experimenting with my own glider and slowing it down. And wow, just unbelievable. So that's the first thing we've got to teach people is what I call 45, 45 and go down to 40 just to experiment. Now, you should be high when you do that, but that 21 does not spin, at least with two people aboard. With one, it might kind of drop a wing, but it's super easy to pick up. I did some forced spins just to test it with Scott. And we did do 45, 45, which is not necessarily any better. 40 might even be better. I used to thermal the 21 at 51 miles an hour, I remember, or whatever, knots, whatever it's indicated on that thing. So the I want to talk about them three things: thermal entry and centering, bank angle and speed, and stick and rudder. And this is going to be different stuff somewhat than what I presented before because it's sort of my new techniques. First of all, this slide is super important. Um, when you're at 45 degrees, the string should be slightly on the outside. And you should be pulling back on the stick, but hardly moving the aileron at all, as far back and stabilize it just in that attitude. And now just fly with rudder. So, for example, if I press on the right rudder when the glide is like this, the nose is going to climb above the horizon and back to the right. If I press on the left rudder, the nose is going to go down. So if I don't want to use elevator or aileron, I can fly this glider perfectly right there with just rudder. Aileron are very damaging things to use on a thermal when you're flying right at the limit. Because the moment you put some aileron, one of the aileron that goes down increases the angle of attack to a possible stall, and that wing starts to drop. So you can't pick up a wing with aileron when you're right at minimum speed. When I was being coached in France by Jean-Marie Clement on a 28-meter Nimbus 4D in the Alps, and we're turning tight, and he says, Fernando, if you move that aileron, you're going to kill the two of us. And I intuitively would enter turns with aileron, he would stop it. And if I was in a thermal and a wing started to drop and I tried to move that, his hand was so ready, that if I tried to move the aileron, he would stop it. Says, if you move the aileron, you're going to kill the two of us. And you don't want to be moving the elevator either, because that's just, jockeying at speed and so forth. So the first thing you've got to do is you got to practice in your own glider, flying with the stick all the way back as slow as you dare and controlling the airplane with rudders. Once you learn that skill, it would be magical how well you can balance it on a thermal and really feel the thermal because there are no control inputs, confusing your seat of the pants. Okay. So I think the first thing is you got to learn to fly slow with primarily rudder.
I got a question.
Then
If you
questions
fly
on that,
really slow, oh,
Joe?
if you're flying really slowly, aren't you on the opposite side of the polar and the airplane is actually not as efficient?
You are if you start stalling, if the wing starts bubbling, you are on the backside. But remember, the polar is what you're looking for is the least sink, not the best all over D.
Yeah, but
So
well, I have my picture off. Hang on. Yeah,
yeah,
but
sorry, Joe.
the polar is going to go. It's going to go
Mhm.
up, but on the bottom side of that, as you get slower, it drops off too.
Exactly. So here's a polar, right? Now draw it just like you did.
Okay.
Let me think about here. It goes like this, it climbs, it starts to peter off, and then it drops.
Right.
You want to be right here at the top point of it, which is
Okay.
not the best all over D. It happens, though, that you got to discover what that top point is. And that top point, because once you get very sensitive and once you are really doing not moving ailerons and not junking elevators, you're going to be very sensitive. You're going to feel the bubbling, you're going to feel lift being dropped, and then you taper off. I'm not saying that you should thermal the K21 at 45-40, but I am affirming with great certainty with two aboard, heavy people, you need to thermal that thing at 45-45 for practice.
Right.
45 is too much, but you've got, remember, we're trying to skill develop here, Joe.
Right. No, I
And
understand.
in reality, we're going to thermal at 35 to 40 degrees of bank and about 40 to 45 speed.
Right.
But in order to get really good at that, you actually need to know, the extreme case, which is 45 degrees and 40, right where the plane is stalling, right where, okay? So the skill you're trying to develop is not yet fastest possible climb. The skill you're now developing is airplane control
Gotcha.
at the limit. Okay, so because with the thermal bubbling and with the thermal gust and so forth, you are going to be at that point at sometimes. Sometimes you're going to get a gust or this, or the wind's going to drop, and you're going to have to know how to control instead of letting the thing drop and climb, drop and climb, in a thermal. So you got to learn to control at the limit. Okay, we're talking about
Okay.
skill development.
All right. Thank you.
Any other comments?
Yeah,
That was great, Joe. Thank you.
Fernando,
Hartley.
the actual climb depends a lot on the characteristics of that particular thermal too. But for practicing controlling at the least controllable speed is really important, like you say.
Exactly. That's what we're trying to do. We're practicing controlling at 45 because you're going to have to pull 45 in order to bank tight to not go back into the sink. Once you discover where the lift is and you start moving towards the sink, you pull for actually 50 degrees and pull back really hard. So you're actually going to use that really 50 degrees and 45 or less to pull yourself away from the sink. Now, the characteristics of the thermal, the other thing I've learned is that the smaller the circle, the better. Period. End of story. I don't care about the characteristics of the thermal anymore. You want a small circle. Now, the bank angle is something else to be discussed and how to achieve a small circle. We're going to talk about that. But the smaller, the better. I haven't met yet a thermal that a larger circle is better. So, to that point, angle of bank versus circle size. This, of course, is a chart that is probably calculated at a glider that weighs about 8 pounds per square foot and 7 pounds per square foot. Different gliders, of course, are different. But Reichman says that the optimum angle bank is about 40. And in world competition, fairly large Polish thermals, large Cordial thermals with a big cloud, somewhere between 35 and 40. But don't be too influenced by that because you want a smaller circle as possible, and there's only two ways to achieve a small circle. And this is the most important chart that actually revolutionized my thermal, okay? I used the thermal at 50, this is a much heavier glider. This graph, the numbers are not going to be exact for my glider because this is a 7-pound glider. I'm at 10. So but assume this. I was thermaling at 57 knots, which would take 22 seconds and 40 degrees. This was my chosen combination in the JS1, 3, the JS3. Okay, that was my chosen combination. And it took 22 seconds to go around. Then I slowed it down to somewhere between 45 and 51. And this 60 feet or 110 feet radius decrease is an enormous difference. An enormous difference. I mean, it makes 50 to 100 feet per minute difference. When you are slow it down like this, you get on the inside because also the circle is smaller because it's only taking you 20 seconds to go around. You're actually passing people on the inside, and even though you're turning inside of them, but you're going around, and what takes 22 seconds, if they're opposite you, you're kind of catching them because you're only doing 22 seconds per thermal. So instead of catching them, you can afford to actually move over to here. You unbank to 35, and then the green is the area where the glider doesn't stall, and you can actually maintain that radius around, and I can go from here to here. Oh my gosh, it is magic. It is magic. I mean, this is what Carl would do to people. In the seniors, for example, Carl and Sarah would slow it down and bank. They actually go this way. They for a given speed, instead of thermaling like everybody else was thermaling here, they thermal here. I mean, this is the crowd and the seniors. This is Carl Sarah. Okay. I mean, they're going around in 16 seconds. So they're going, they're passing everybody on the inside, but they are 100 feet inside of them. Just going, bah! Okay. So this is so dramatic. I mean, I just cannot emphasize. It takes a lot of racing, and I've done a lot of racing. I've done how many? 30 or 40 days of racing so far, this flying against a lot of top competitors. And when you slow it down, it's like magic. You can slow it down and tighten Carl style, or you can slow down and open up Fernando style, whichever way, you're more comfortable. But you got to learn to fly that glider just above stall. And in order to do that, you can't use aileron and you shouldn't be using elevator because then the speed is all over the lot. You're going to have to control the nose with a lot of rudder, just a little bit of elevator against the guts. Questions? Hey, Joe, does this chart make sense to you? All the trade-offs?
Absolutely. I mean, if you look down here at 62 knots, right there, and at 40 degrees, 380 380 feet. That's a huge, huge circle. So you're going to be flying in and out of whatever lift there is, and you
Completely out.
just
And the difference, yeah.
Yeah, and so I mean, just splitting the difference, 5 miles an hour, you're taking 60 feet out of that.
Yes.
So and then 60 feet again out of that. Small circle is key, just as you've explained.
And the good thing is now you're next to the bird, so you can use the bird as your core marker. The other thing I learned to exercise myself, I'm now using birds to mark, and they're not perfect. But when the bird thinks the core is here, and I think the core is to the north of the bird, I circle there. I use the bird as my point in the sky to make sure my circles are, consistent and I'm displacing correctly. So I've learned a lot by flying with birds marking for me. Okay. In fact, that was one of the things I'm going to talk about next is I didn't use the center as well. And this, by the way, is the biggest problem people have. They don't know how to center well.
Yeah,
Okay. And
Fernando,
yes,
one, just a point of clarification, when you said at the stall, it's at the stall at that degree of bank,
correct.
not the published stall speed in the handbook.
Right.
Yeah,
Yes. And
load
you and
factor.
I both know the math. But the stall is the point of flying, for example, 21 at 45 40 is for you to feel the stall. When you fly your glider at the stall as it's stalling, don't worry about it. If you are good with the rudders, it's going to just kind of mush a little bit. It's not going to drop a wing. And the moment a wing drops, you go with the rudder. You just you take that nose like this or like this, up or down without pulling the elevator. If you pull in the elevator, you're going to stall. You use the ailerons, you're going to stall. So just balance it with the rudder, and the plane will just sit there and dance. And if it drops a little bit, you'll drop flat. And if one wing drops, you just rudder it around. And so once you know what the stall feels, you add 2, 3, 4 knots to that speed, and that's your thermaling speed. To your point, Joe, you don't want a thermal right where the curve is dropped. You want
Right.
to be a little bit faster. But if you don't know what the stall is, how are you going to know what 3 more knots above that is?
Yeah, I took the liberty of looking at the ASK 21 Polar, and it really does not drop sharply until like 39. Again, that's Hartley's point. This is in flat, and it's not in a turn with the load factor making a big difference, but it's pretty flat until you stall. So that
Yeah.
what I mentioned really doesn't, especially in the ASK 21 Polar I'm looking at. It does not seem to make a difference. And you're not gonna, well, with me in it, you're not gonna fly that thing at 40 knots
Well, with me and
in a
Scott, we
steep turn.
did. Scott was witness. He saw it with his very eyes. I couldn't believe it.
Yeah, you explained this to me at Chilhowie when we flew years ago, and we you and I practiced that, and both of us in that plane, and we were still able to get it back down between 40 and 45.
Yeah. So my point is discover what that minimum control airspeed is at 40 to 45 degrees, and then add a little bit, and you're going to be just climbing much better than before. What's the problem? So, bottom line, fly as slow as you can. Speed matters more than bank. This is a truism that I didn't realize. I was trying to bank it real tight, trying to stay in
So
the core, show off how tight I could bank. Hey, I can fly inside people and pass them with less bank by flying slower. All right, enough said. Now, this was a thermal. Remember that chemical fire down that we had once? What
Yeah.
I get from this is that the thermal goes up, then it goes over, it goes up, then it goes over, it goes up, and then it goes over. You got to keep recentering. So if I'm thermaling here, and of course, maybe I'm not climbing as fast as the smoke. Let's say I'm circling right here. Can you all see my arrow?
yeah,
Yes.
Okay, so here I'm circling, but I'm not climbing as fast as the smoke. Then boom, I fell off the bottom. Which direction do I correct?
Wind.
Upwind. In the absence of other information, go upwind, young man. So I go boom, boom. Okay, now I'm thermaling. Good. Oh man, this is good. This is good. I got it. I got it. I got it. Oh, so all of a sudden, I got to correct upwind. Now I'm thermaling here. You get the idea? You've got to keep correcting. Usually towards the sunny side of the cloud, upwind or upwind at the sunny side of the cloud. That's a killer combination, which is southwest. But you just got to keep correcting.
it's a heck of an inversion.
Yeah. Now, how you correct is very important. If you unbank with a lot of aileron or let your speed accelerate, and all that stuff, you're never going to know where it is because the air is going crazy with all your variations in your flying. Okay, so let's talk about that. The classic, you coming along and beep, 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 beep. Okay, you turn. That's too early. go ahead and let it go beep, 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 because there's delay. Remember the strongest beep is going to be here, not here. So it's going beep, 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 beep. Now you turn. Go ahead and explore the whole thing just in case it's better, because remember, you should always explore upwind. So let's assume that this direction is upwind. So I'm coming along and I'm cruising and I feel something. I turn into the wind and start exploring it. Or vice versa. If I'm coming from that direction, well, I turn downwind in this case because I'm going that way. If I'm going down, I come here, I start feeling beep, 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 beep. I turn into the wind, I keep going, that kind of thing. But don't turn too soon. And then when you turn, you got to pull and pull really hard. I mean, you got to pull and bank about 50 degrees to tighten up the circle because you're going fast, remember? So you're going fast, you're going about uh, well, let me pause right here. The 21 only has three speeds, 45, 55, and 65. 45 for circling, 55 when the air is bubbling, and 65 for cruising along. Forget speed to fly, forget everything you've learned experientially. You fly at 21, 45, 55, 75. For your plane, for my plane, it is, I'm going to round it to 50, 75, and 100. I fly at 50 in a thermal, 75 when it's bubbling, and 100 when I'm cruising in knots. That's it. And when you're coming in, so you slowed it down to bubbling speed. Let's call it bubbling speed is 55 in a 21. It's going to require a real sharp bank and a hard pull to make that circle that good. Then you can start unbanking it and you're going to maintain the circles you unbank because you have less speed. So to fly a circle, it actually requires more bank when you're fast, of course, as any fighter pilot will know, than when you're slow. If you leisurely bank to 45 and get to 45 degrees when you're here, you're way out of the thermal. Now, what I love to do is I bank to about 70 to 90 and you've got to actually go semi-inverted. I bank 110 right here. So I'm pulling back and then I start unbanking from 110, to 70. Right here, I'm on like knife edge, 90 degrees of bank, just pulling as hard as I can to stay in the core. I'm unbanking, 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 slowing down and go. But that's, if you enter at 110, 120 knots, you've got to really bank and pull. See, like pitch up and roll in. This is the example of what you have to do. You go through the thermal, beep, 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 yank it in, and a roll out. Okay, now, I think that this is where we're going to do the exercises. This was a pretty lucky pull because they went right through it and they guessed it correct way and did good. But let's suppose, and hardly, you may not be able to see this, but because I'm going to do the little bubbles. Actually, let me do one more here first. Steve Villan, who's an excellent pilot, and Steve and I are now, because the new rules allow us to pair fly, we started competing as a pair. Competing as a pair means that we got to stay together. And with my improvement in thermaling, I'm out thermaling him, and then it becomes hard for us to stay together. And I realized because we would start kind of together, but then I would start out climbing him on the inside, which gives me a good view of him. And he was doing a little bit of exploration and flying a little bit too fast. And he was just exploring, going out of the thermal in directions that he shouldn't go. And it turns out that he did not have a circle thermal optimizer. The LX thermal optimizer is just like the UDI, which has little balls. Do you use yours on the UDI, Mitch, or not? The little balls, the thermal optimizer?
Yep.
Even though it's not compensated, it still works?
Well, that combined with the old seat of the pants, I mean, if there's a choice, I trust my butt before that thing.
Amen.
Yeah, so I finally am learning how to use the bubbles in conjunction with my seat of the pants, but Steve didn't have the bubbles, so we put the bubbles in. We're going to fly together hopefully on Thursday, and hopefully we'll be able to climb together. But this is what's happening to him and a ton of people that I was racing with. Let's start here. Okay, so you're going through, being very good pilots, they pull really hard, and then it starts getting weaker and weaker and weaker and weaker and weaker. They come around really weak. Now they know right here's the weakest point. They know they got to fly. Remember, you always go towards the inside wing points to the center of the thermal. But this is what a lot of people do. They open up, they're going towards the center of the core, and they fly right through the core, come out the backside. Oh, shoot, okay, it's weak. Let me recenter it again. Whoop, through the core, come out the backside. And Steve was doing that, and I would center, or let's say that I was doing one of these maneuvers, and I would say core right here. Let me illustrate. I say good, really good, turning around. 3, 4, core. I say I'm at 3 here, 4 here, so that he knows he's behind me. We're pair flying. We're trying to be on the opposite end of the sign. So when I say core, he's here. And he would go to the core very diligently, obey me. I said, no, 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 Steve. When I say core, you're supposed to go around it, not through it. I can't tell you how many people go through the core instead of around it. Okay. This is the standard of most pilots, including me, before I started getting better. And when you have a bird, so now that we pair fly, we get opposite. So we are, if one of us goes through the core, let's say that I'm here and I'm about to go through the core, and I come out here, I say to Steve, more south. And he comes and he goes more south, or more north, or more west. So we're always orienting ourselves and like putting a stick on the ground of where the core is, or a bird that marks the core. So the second lesson that I want to focus on, you all to focus on, in addition to flying really slow, is visualizing where the core is and flying around it, not through it. That sounds ridiculous to even have to say that, but you got to fly around and not through the core. Dieter, I like your comments. Are you on the line?
I'm on the line, yes. Well, this is, I think, something I do sometimes, what you're showing here. So yes, the question of how exactly to avoid it if you're by yourself is the other question.
Yes, and that's where we're going to go with the bubble exercises next. Dennis, any thoughts or observations? Oh, now you're back to mute. Unmute again. No, you're mute. Unmute, Dennis. Dennis, unmute.
Fine.
There you go.
There we go.
Go.
I suspect I'm doing exactly what your diagram shows here. I need to, try and identify the strongest point and spend the most time in the center. But I always find I'm strong, then I'm weak. I'm strong, and then I'm weak.
I used to do that too, and then I would be very frustrated because no, wait a minute, I'm correcting. The weak point is not always the same point because the cardinal rule is never fly through sync twice.
Yeah.
So I know that I was in sync here. I'm in sync here. I ain't going to go back here. Okay, good. But I go through it and I come back and now I'm in the sync over here. I said, wait a minute, I thought I moved the circle. And then I do it again. Oh my God, now the sync is over there. So let me move the other way.
I think one of the things that occurs to me while I'm flying is like, when should I tighten the circle? And of course, when you feel you've centered it, but when I feel like it flattens out, turn hard back in is what goes
here's the correct way, which is pretty obvious, Dennis. But this is what was frustrating me because I was also moving and I was using the technique of moving towards the inside wing. but I did, you know, and I was tightening when he got strong, but I was tightening right here, as this diagram shows. What you
Okay.
got to do is you got to go around the core and then tighten really hard, you
Yeah.
know, so you don't go back out to the sink.
I think I
Make
tightened.
sure first you go around the core before you tighten. And
Yeah.
then when you know you're going towards a weakness, you tighten really hard.
Okay.
So if I'm coming around here, okay, I should go around the core, not through it, tighten. Now I'm going back towards, I know the weakness is over there. This is where you got to tighten because you
The
don't want to go back here because you already know there's weakness there.
the other
This is what
thought,
Sebastian does. Sebastian simply flaps, I tighten away from the weakness. That's what he does.
the other thought was if you're listening to the variometer, what's your lag time on your variometer? And
It's about 60 to 90, 60 degrees of turn.
okay.
So, you know, when you are here, the variable is reading here. When you are here, the variable is reading here. You fly through the core and you think that the core is here.
Okay.
You know, more or less.
Yeah. So lag time in seconds is, well, I guess depends on your bank, right? But 6 to 8 seconds.
You're doing a circle. If you fly at 21 really slow, like I said, it's a 20-second turn. So
Right.
it's 5 seconds per 90 degrees.
Okay.
You know, 3 seconds is about 60 degrees,
Okay.
which is the lag on the variable.
Okay. So it's not that long, but yeah. So I'm wondering on the label what it would be.
Yeah.
Yeah.
So this is what I see the majority of actual good competitors, and I'm observing them because once I get good and I'm very nicely circling over here, and I'm watching my pair or some other good competitors doing this below me, you know, they're not exaggerating, but they're doing a little bit of this and a little bit of this and a little bit of that and a little bit of that, and I'm just out climbing because I my farm, I punch whoever I am thermaling with and I measure my difference to see if I'm gaining or losing on them. You know, and I start, you know, 50 feet below, then I'm 100 above, then I'm a 200 above, 300 above, 400 above. I say, bye, sucker, I'm out of here. You know, but I started gaining like I'm measuring, you know, and then when Steve started falling 600 feet below me over, you know, 5 or 10 minutes, we're in the same circle, we're talking to each other, we're trying to help, but he was having trouble flying around the core, and he's a very good pilot. You know, I mean, he's going to be winning very soon. I started realizing that that default centering technique of which is the correct technique to use. Don't get me wrong. You have to move the circle towards from the weakest point, but somehow you got to get a picture on your mind. If there's a bird right here, it's very helpful. If there's another glide, it's extremely helpful. The cloud wisp, you got to mark. If anybody flies Condor, you know how you can cheat with a little tube in the air? You can see the thermal. You got to fly around the cores. Thomas, your comments, maybe.
It's all very good points. So
Yeah.
Uh,
Scott, your
Fernando,
thoughts.
Yeah, again, we're looking at a textbook thermal cross section, and my experience at Monroe is that the textbook thermal cross section, particularly on blue days, and believe me,
Yes.
I know blue after 6 months of this nonsense. It is
Yes.
very different when you have a day with nice Q, and for the guys going down to Cordele, best of luck. Hoping you got the great cloud bases and the big motherships up there. Because yes, now you're dealing with the classic Q cross section. I have
Yeah, and they're elongated. Yeah.
that.
So that's a perfect entree. Steve, Victor, you just joined us? I think you just did. Okay.
Yeah, but I'm driving home from the office.
Okay. So now to Scott's point, which is a perfect segue, let's talk about uncertain thermals. Let's suppose you don't know where the thermal is. You know, it's not like this diagram and very circular. See, we're going to work as a team here, and we are going to practice. Okay. Other than Hardy, there's everybody else. So this see little dots, yellow, red, blue little dots.
Yes.
Yes. Hardy, do you see it now? Not yet. Okay. And we'll figure it out later.
Yeah,
All right.
I
So
don't
here it
see
is. This is the way the thermal centering tool kind of works in the LX 9000. So here we're flying, we go beep, 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 beep. Typical, right? I mean, this happens to me all the time. Okay, now what do I do? Let's go again. Beep, 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 beep. What direction should I go? Mitch, you're the first one to say where would you want to go next?
To
You
the
want to
left.
draw a pin right here? Which way do you want me to draw? From here to here?
Go to your left. Go to your left.
270, right?
Here,
It's almost
Joe?
like you turned the wrong way.
Yeah.
Okay, yes, I probably did.
Yeah.
Yeah.
Okay. So, we know that this area is poor. That means that somewhere, let me see if I can move this. Hang on just a second. Give myself more room here. Okay, so do y'all see a pointer
Yeah.
moving around? Okay, so generally speaking, we know that this area is poor, but the thermal might have been here, it might have been here, or it might have been here. So we eliminated kind of this area, but we haven't yet eliminated all the above here. So the way I like to do it is to start here and then search kind of that way. If I go here, I might miss it if it was over here, and this was just a vario lag going on, a little vario lag. So I tend to do a teardrop. Actually, in this case, I would do a teardrop right to about here where it began to get good. So I would do this. Okay, now let's paint it. Oops. Yeah. Y'all see what's going on? Do you see the three dots?
Yep. Yep.
Okay, now I've got a hypothesis, okay? I kind of know it wasn't here, and I kind of know that somewhere between here and here is probably it. All right, so to your point on when do I tighten? That, because I know by no means should I ever get to this side of that line because we know it's weaker and it's stronger here. In fact, the gradient, if you're skiing up a hill, the most likely gradient is from here to here. Okay. That's the most likely place for the thermal. And then I continue like this. I tighten really hard right there. And the reason I tighten really hard is I use Sebastian's principle. I know this is weak. I'm not going to go there no matter what. But the peak might have been right here, and I might have flown right across the thermal. So I continue. I go here. Oops. Forget that. I go here. I go here. I go here. And let's say it's really good here. Now I'm forming a hypothesis, and I am probably going to try to do this. And then I'm going to do it again. This is the critical moment. This is what I learned from a French team member. Once you got your hypothesis pretty good, do two circles that are perfectly round with no speed variation, no bank angle, and then compare the bubbles. And if you have bubbles, I'm going to have a bunch of red bubbles here and maybe orange bubbles here and really big bubbles here, little smaller bubbles here. When all my bubbles are equal, I know I got it perfect. But if you're still hunting, you don't really know where it is. So once you kind of get it, you got to slow it down to that super tight circle, that super tight speed, do two circles, and then it says, no, wait a minute. It's a little bit, I'm getting some of these over here. Sorry. I'm getting, when I went over that way, I'm getting a yellow over there, another yellow over here, and I'm getting a bigger, imagine this is a bigger red over here when I repeated the circle. Okay, so anyway, move around. But there's three principles we talked about here. One, once you go into lift, stay that direction for a while, then turn really tight. If you turn the wrong way, which two times out of three, you will turn the wrong way. Does everybody know why it's on a 50-50 chance? You only got a third chance of turning the right way? Dieter, you know why?
Well, if you let the wind kick up the wing, then yes, or the lift.
Yeah, no, simpler than that. Okay, there's three possibilities, right? You can, when you go into a thermal, the thermal can be on your right, it can be on your left, and it can be right on your nose, and you went right through it. So if the thermal is on the left and you turn right, you miss it. If the thermal is on your nose and you turn right, you also miss it. And so only on the case where the thermal is on your right and you turn right do you get it. So if you go perfectly through the center of the thermal, you're going to miss whether you turn right or left. Okay. So don't be frustrated if your first turn is off the thermal, because unless you are Sebastian and can perfectly feel wing and everything else, you're more likely to turn the wrong way. And so then the real art is recognizing that and then putting a mark, no matter what the shape of the thermal is. If it's a linear thermal, an elongated thermal, a triangular thermal, you mark the zone off of it. Then you move across, and and if it's still weak, let's say that we came across and it's weak here, still I keep going because it might be here. Maybe I turn too soon. It might be here. Does that all make sense? I mean, it's kind of obvious, right? It's real simple.
So I often get bubbles
Harley,
on both sides, on two sides of the circle. What do I make out of that?
repeat the question, Dieter.
I often get bubbles on two sides of the circle, like left and right side, but not in between. Is that too
Oh,
cold?
that's a good one. I don't have, let me see if I have something to show you on that. Um, hmm, 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 hmm. Um, Let me try something here. I hid that. Okay, so I don't have it because I have that slide, but I can't find it real quickly. What you're dealing with is an elongated multi-core thing, okay? So there's a core here, and then there's a core here, and another core here. I'll find that actually, because I think it's a really important point. Bear with me here. Um, Let me find that. Because that happens a lot. To Scott's point also, the thermals are not necessarily those perfect circles. This is what you encounter in real reality. Um, Let me see how I can share this. Y'all see this slide?
Yep.
You see a slide with kind of a linear bubbles on the wind? Somebody give me a yes.
Yes,
Yeah.
yes.
It's
Okay.
kind of a
So this,
stream. Yeah.
yeah, this is very, very often the case when you have the wind and the alignment. In fact, if there are clouds, this is called the welcoming cloud and the main cloud, and then it's starting to weaken and then weaken, okay? Um, and if you are thermally in very wide circles, like 500-foot diameter, some of the stuff that we saw, you're doing this, Dieter. Does that make sense to you?
Yes, although I don't typically have a 600-foot circle, but yeah, it could even happen if you fly a little tighter. It'll still show that.
Yeah. This distance is very small, actually. I'm talking about 600 total. Glider to glider, when you're thermal somebody, 300-foot diameters, let me put it, radius, let me put it that way. So this distance could easily be. Um, and so when you get one of those where you're getting yellow little blue balls, and then you get yellow, then you got a red, and then you got red again, you're going to have to say, okay, you follow Sebastian's rule, which is real simple. Remember Sebastian's rule. When you're here, it says, I refuse to fly through weakness. You pull 55 degrees of bank, pull back and tighten up. Sorry. Tighten up and then try to find the core of this one. If you're really tight, you're going to be in course. If you're having trouble in and out, and if you say for example, one of the things that I say all the time when people that are not good thermalers, beginners usually say, oh, the thermals are really turbulent today. You know, you kind of look at that and you don't say anything because, they don't know any better. The reason they're turbulent is because they're in and out, and the thermals are very um, bubbly, on the edges. And turbulent on the edges. If you really core tight, they're usually very smooth. So one of the indications you're not in the core is if you're saying the thermals are hard to center today or the thermals are bubbly. That's an indication of bad centering technique, basically. Much more of that than it is the atmospheric conditions, in my experience. I mean, and I have flown Hobbs thermals that are scary as can be, and they're very difficult and they're very broken up. But you're talking the difference between 12 knots in one place and 5 knots on the other. That 7 knot difference when you go in and out is pretty violent. Um, in our thermals, it's +2 here and +5 there. They're not that violent. And if they're violent, you're going through the center and then coming out the side, coming through the center, coming out the side, going through all the turbulence. Um, let's see, who hasn't commented? Marty, you hadn't commented.
Okay, no, I agree with you. On the that one that you were showing, instead of turning in that thermal, why wouldn't you just keep going straight, through that cigar shape?
Oh, yes, now you go. Now you're really doing advanced theory here. As I say, to turn is to admit defeat. You're absolutely right. If you knew that, let me reshare it. Let's reshare it. The cigar. Yeah. And that's why when you're in a good line, you just keep going. And this is a 3 knotter, this is a 4 knotter, and this is a 6 knotter. So you just keep going. And only when you got a cloud street or in blue, in blue, it's even more important to do this. Let's say that I was flying from, can you all see my cursor?
Yes.
Actually, hang on. This is so frustrating. I got too many presentations open. Let's take that presentation. Okay, don't worry about it. Anyway, when you got that cigar shape, you just got to continue. Um, especially if it's in blue. One other point that's worth making with that slide, if I can ever get it back. Um, Here it is. Huh. Okay, that one. Um, let's suppose that we are not aligned with the street. It's worth aligning with the street, whether it's blue or not. But let's suppose we are flying from up here, where my arrow is, and our destination is here, down here. Y'all see that? Somebody give me a thumbs up or a
Yes,
yes.
yeah,
Yes.
you can see it.
Okay, thank you. Okay, so what I used to do, and a lot of Americans still do, is they come like this. They look at this. This is the darkest, strongest, tallest cloud. And they go like this. My coach in Poland would go nuts if I ever did that. Says, Fernando, what the heck are you doing? Go, this will cost you almost nothing. Go to the welcoming cloud, then start this way, and then this way, and then this way, then exit out. You don't know whether the welcoming cloud is the strongest. Sometimes the little baby one is the strongest because it's really the emerging one. The next one is already overdeveloped, and maybe there's another one that's reemerging here. Don't just pick a cloud. Pick of course, you don't want to go backwards and go like this. But if you're coming in, you're going to go here, 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 and exit. You might say, okay, that one is definitely dying. But I mean, this is like gliding 101 in cross country, okay? Especially in blue, this is even more important. You get a thermal here and you climb, and then instead of exiting this way, you go like this for a while along the wind line in case there's a stronger one next to it. In blue, it's particularly important to exit along street lines. For example, if I find a good thermal here, I'm not going to go for here back out on course. I'm going to go a little bit for a mile or so along the wind line before I exit. Especially, this is a pretty severe case because this is almost 90-degree deviation. But a lot of times I'm coming from down here and my direction is here, and it costs me nothing to climb, exit. Oh my God, even better, exit and then go. This little deviation is much more efficient than just climbing here and then going out. Okay? So let's kind of start moving to, I think my thermaling lesson is almost over. Let me stop share here, figure out which slide I was sharing.
Fernando,
Uh,
Fernando, what is
hello,
paying your attention?
hmm?
Fernando,
Yeah,
before you finish on thermaling lessons, you have not mentioned the sensations of acceleration,
yes,
which help really fine tune what you see on the variometer.
yes. Let's talk about that. What do you see on the screen right now?
You,
Only me? Okay. I'm going to wrap this with what you're saying, Hart, and a few other things. I shouldn't have had so many things open on my screen. Okay, hopefully I've got something that's titled Thermaling Syllabus. These are the six things I'd like to leave this group with. First, aircraft control. This is your to-do between now and Cordio, and what you to do in Cordio if you are not on a cross country just practicing. Okay, thermaling. These are the six things you got to the list, and I'll mail that slide to everybody, this very slide. First, practice 45 degrees near stall speed, and then practice your speed down to the actual stall. Okay? You're not going to be thermaling that way every day, but you must know how to do it perfectly. You're going to be thermaling at 35 to 40 degrees, and then at that stall speed that you discovered at 45 degrees, that speed will be plenty fast enough at 35 to 40. But if you have to pull to 45 to move away from the sink, you've still got enough speed to not stall at that point. So figure out what your speed is at your weight at 45, then thermal that speed at 35 to 40. 35 when you're opening out, for 45 or 50 when you're trying to avoid getting back into the sink. Speed control. Effects of horizontal gusts. A horizontal gust occurs when you go outside the boundaries of the thermal. Remember, the thermal is almost a solid column of air, and the wind is having to flow around the thermal. If you're not in the core and not thermaling tight, your speed is going to be very hard to control, because if the wind is going up and you come out into the wind, your speed increases, but the vario says, beep. The vario doesn't know when there's more energy. In other words, more wind on the nose, which means more, it thinks you got more energy, more. And so it's going to tell you the core is outside over there. So if you don't thermal tight, one of the things that happens is you step out of the thermal into the wind. And what's even worse, when you on the other side, you step out of the thermal with a tailwind and it looks like you're in sync. And you discombobulate completely. Okay. So horizontal gusts are very problematic. And horizontal gusts are created by moving out, in and out of the core of the thermal, where the flow is vertical. Okay. So the only way to know whether it's a horizontal gust or an up gust is your seat of the pants, because the vario is going to mislead you and your airspeed indicator is going to mislead you. And the only way to prevent horizontal gusts is to thermal tight in the core. We talked about elevator versus rudder and attitude control. Keep the elevator pretty steady. Do use it, but it must be used in combination with the rudder. The way to pick, when you're at 45 degrees, you got to pick up the nose with a combination of elevator and rudder. The elevator picks it up this way, the rudder picks it up that way. It's like a Viteo Bonanza, right, Harley? And you want to learn how to fly with a slight slip, meaning with the stick up. So after you got good aircraft control at the stall, you got to have speed control through gusts. Recognizing thermals. We talked a lot about that. You just got to practice. And one exercise that I recommend everybody do is, even though the thermal's around, after you center a thermal, you get out of it and then fly through it, and then fly through it, and then fly through it, and then feel what the inputs are as you crossing you know where the core of the thermal is. You got it marked in relation to the cloud. Exit into the wind, come back through it, exit the other side, make a U-turn, come back. So in other words, start passing through thermals on purpose to learn the correlation between the seat of the pants and your vario. Does that make sense? In other words, we're talking about skills development. We're talking about doing things so you learn new skills. So, and then of course, once you correlate all of that, you're going to know when you are at the peak point of the thermal, which is going to be much more confirmed by the seat of the pants than by the vario. And then you got to learn how to do the really sharp entry with a lot of rudder, a lot more rudder than aileron. Just practice entering with hard full rudder and let the aileron trim it out. Which way to turn? This is to advance the topic. I won't talk about turbulent signatures. But after you turn and stabilize the speed and bank, and you know that you are in the core, just around the core, past the core ideally, you turn sharply away from the weakness. Okay. And when in doubt, turn upwind. I mean, the default is always turn upwind. When in doubt, turn to whatever side the wind is blowing. Centering is real simple. Fly away from weakness, go to the core, and fly around it. What is not simple is orientation. People don't have spatial orientation when there's not a marker. If there's a bird or another plane, it's easy. But as Steve and I do, we say more to the south, more to the north. You got to talk to yourself and say, the core is more north, and I'm going to displace this thing more north. North is a lot easier to know because you're flying with the sun and all of that, then kind of, or, pick a point when when you're in the weakest point, the inside wing points toward the center. Pick a barn over there, pick a field, pick a lake in that direction and go there, but kind of don't go all the way there so you don't fly through the center. So you must have spatial orientation and talk to yourself. I'm going to move that way. I count 1, 2, 3, which is about 300-foot move, and go and turn. Those are the 5 skills you've got to learn how to do, and they are amazingly, I mean, these are long learning curves, actually. And the opportunity for doing better than you think you are doing now is enormous. I can improve a lot on these myself, and I'm going to work to do it. So finally, just practice. And practice means you go up and down, a good thermal, then go find another thermal, and develop some wind awareness. But the point is, do not stay in the upper 500 foot at a thermal. The thermal signature up there is very different. It's weak. Meaning, if it's weak, means that the difference between the good spot and the bad spot is small. When you're in a 2-knotter and the bad side is 1 and the good side is 3, that's too small a difference. When you go down low, it's going to be 4 and 5 knot, especially early in the day. The ideal time for thermal is 12:30, 1 o'clock, when the thermals are the strongest, especially down low. And they get weaker as the day progresses, typically, at this time of the year. So go early, go low, and then when the thermal is a little smaller and narrower, but it's got 5-knot core and a 3-knot and 2-knot outside, you can really feel the difference between when you step out of the 2-knot and the 5-knot. It's very hard to thermal when it's 1 to 2 knots. You gotta learn a whole lot thermally in 1 to 2 knots. I mean, I learned a tremendous amount because I did a lot of thermally at 900 to 1200 feet on 1 knots against another glider, and we were optimizing. But that's not the point of this. When you're flying that low and you got to take something like that and you got another glider, it kind of helps you. But it's a lot easier to learn in the middle part of the high band than in the top part of the high band. So do not pulse it. Come back down, go find another thermal. All right. Yeah, you're kind of a novice. Give me some of your thoughts and reactions to some of these exercise, or I call it a syllabus, skills you got to learn.
Well, I'm frankly uh, uh, sort of intimidated by all this. What I get out of it though is it's so important to get a seat of the pants feel and to the core, and so I would look forward to to getting there. As it stands right now, I mean, I'm embarrassed to say I haven't really
There's no, Eb,
experienced
there's
the
nothing,
thermal.
Eb, there's nothing embarrassing about where you're at. You say, not bronze yet, in fact, not even rated yet. When you get in there and you start practicing, before you can do this, you need to be able to handle the plane your own way and be safe. Flying just above a stall, having only had 5 flights in a glider is probably not a good idea. So what you want to do when you're first thermaling, you find a good way to control your airspeed. That's one of the things that people don't understand is that if you're chasing the nose on the horizon and your speed is going up and down, you're not flying in a circle. You're flying ovals and dipping in and out of your circle, and you're dipping in and out of the thermal. for you, as you study and as you practice, when you first get into that glider, get in and focus on maintaining a bank angle at the right and a nice healthy speed, say 45 or 50 knots. 50 knots is fine. And if you're around other gliders, make sure it's a little higher than that, 50, 55 knots. So you have positive control. Um, but these things here, a lot of this is very on a further end from where you're at. That I hate to hear that you're intimidated by this. This is, it's three-dimensional chess, and he's teaching. There's a lot of old farts on this call that have been doing this 30 years that are getting a lot out of this. But for you, this is aspirational. So no, don't be dismayed by this or intimidated by this. We all went through this, and we all were where you were, a long time ago for some of us. But this we'll get to fly together. In fact, I hope you get to fly with Fernando. He says he's going to be there for the whole week. I learned a lot from him when I flew at Chilhowie, in doing these things here. And so even after flying 20 years, 25 years, Fernando's teaching me a lot even there. So don't be intimidated. This is you're going to have a lot of fun. But
Yeah,
but
I look forward to it. Uh, uh, so
Hey, Joe, that was perfect segue. Thank you very much.
Very well said, Joe.
Very well, very well. Steve, Wisniewski, have you been able, do you see this slide now?
Yes, I'm at my home desk now, so I can see.
Okay, comments.
Um, that all makes sense to me. Obviously, I missed a lot of the content up front, so I'm consuming some of this for the first time.
Okay, that's
can I
drinking
can
from a
I
fire
ask you a
hose.
question, Steve?
Yeah.
So when you're thermaling, do you fly with just one of the things that I've noticed here, and it's something I did in the Cirrus and what I do in the Twin? Do you fly with any slip when you're slowed down in a thermal, or
Well,
are you keeping the string right in the center?
I read about that technique when I was flying the Globe briefly, and did that, started doing that, flying with a little bit of slip in the Globe, and have subsequently read that with the newer ships, particularly with winglets, that's less beneficial. So I may fly with a little, but I don't do it aggressively.
It never is really an aggressive thing. You will feel as you put just a little hint of slip in it, you'll feel the plane settle into the turn,
Yeah.
and the plane itself will feel comfortable where you have it with the string just a little to the offset, and the nose pointed maybe a little bit further outside, and you'll feel it settle in there, and you will feel it climb better.
Yeah,
Yeah.
and one of the big things I caught this as I was coming in, but you were talking about entering with the rudder. That I mean that's something that I started doing a couple years ago. That's pretty much my primary flight control for entering the turn at this point. So
Yeah.
otherwise, it takes way too long to
Yeah.
get.
Sebastian speaks to that, the reason that you want to have the inside wing a little bit forward, which brings the string up or slip, is to keep the glider from wanting to overbank. As Joe says, if the inside wing is a little bit forward, the dihedral causes that wing to kind of not want to tuck down and stays up, and without you needing to use aileron. Because if you do not put a little, and the older gliders needed a lot more of this, especially the older open class. The modern gliders with winglets and swept wings and so on, much less. But it's still necessary in order for you not to have to use outside top aileron. Um, if you use top aileron to keep the glider from tucking in and tightening the turn, you're putting a lot of drag and then, increasing the stall speed of that inner wing, et cetera, et cetera. So you correct it with rudder and get help from the dihedral.
That makes sense. The big thing that I think is killing me right now is the gusts and being able to separate the
yes,
gust from the audio signals. I need to study up some more on that and try to disambiguate the signals.
One thing that you have to think of it as being an average when you enter. I remember flying with Charlie Meeson one time. In fact, it may have been a flight review or something, and we entered a thermal in the ASK-21. That stick was everywhere. He was chasing every gust and every, especially in the ASK-21, you'll feel the tail raise up when there's a gust from behind you. You'll feel all of that, and you do need to compensate that again, as I mentioned for ebb, maintaining your speed. So you'll need to follow that, but don't chase every beat because they're behind. Just trying to find the mean and find the spots on the circle or in your instrumentation that are telling you where you should be.
Yeah. A lot of times the speed increase is not due to the nose dropping, it's due to horizontal, when you fall off the thermal into the wind.
Exactly.
So to learn to differentiate the two is part of that total
Yeah.
practice of, as I said, there's two things you're really trying to learn: feel the aircraft and feel the air.
Yeah.
I
And it goes
mean,
back
being
to
a great thermal is the knowledge of two things. It's all about feel. It's all
yeah.
experiential learning. Feel the
And
aircraft, feel
it's
the air. Feel the
yeah.
aircraft, feel the air.
And
It,
that's
it
one
was
thing that I'm just starting to get. I mean, it took me 2 years to even start to be able to get that seat of the pants feel. And I don't know, I'm just insensitive, I guess, but I'm working hard to try to
well.
pay more attention to that.
I flew with Patrick Grady's ringer. I forget his name. What was his name? The French pilot. What was his name? Anyway, I've been
Mhm.
flying for 25 years, and he showed me a lot of things about feeling the air and I've been flying for 20 years. So this, again, we're all continuing to learn.
Hey, Joe,
Just
don't feel
go ahead.
bad. I've been flying for 40, but I'm only now, after 3 years of flying the JS3, only now I've got my feel for that aircraft. And as a result, only now am I getting the feel for the air in it.
Right.
I mean,
Exactly. And
seriously,
it
I'm
goes
not
back
kidding
to
you.
your very first slide about that Einstein says is the learning is just, the memorization, but it's the experience that's counting.
Yeah. And you've got to fly at the edge in order to really understand, what's going, disambiguating the signals, as Steve says. I love it.
Right.
The other thing is, of course, coaching, so I look forward to flying with different people to the extent I can to see what your worst bad habits. It's like a golf coach, I can't fix five things, but I'll try to fix the one thing, if I can identify whether it's your. Okay, now let's move on to the other statement that I made, which is a little bit different than our past paradigms, and that is that you decide where you're going at 9:30 or 10 o'clock of the flight. So I'm going to demonstrate how to do that with SkySight. Um, who does not have a SkySight subscription?
I don't. That's Dennis.
Marty? Who else?
Dennis doesn't.
Eb doesn't.
I
Do you
don't.
have it, Thomas?
I do.
Good.
I do not.
You do not, Joe. Okay. Maybe after you see what I'm going to show next, you might want to consider it. So let's go to how to plan a flight with SkySight / you can use CU also. So let me go to different share here.
Your, your camera moved and you look like you need a booster seat,
Who,
Fernando.
me?
Yeah,
Yeah,
you're
I'm sorry. I keep moving my screen. All right. So this is LightSight, and LightSight is finally good enough for real serious consideration and work. It didn't used to be, but LightSight is now good. That's why I'm now using it. And this is the first thing you do when you fire up LightSight is you look down here on the bottom left corner where it says updated at such a time. So let me go back. This is today's light site, Tuesday the 13th. Kind of irrelevant, but let's look at Wednesday. Let me refresh it first of all.
Alexa, turn
Okay.
on living room lights.
Are you still seeing the screen?
Yes. Yes. we see
Yes.
it.
Okay. Darn it. I'm very
Alexa,
disappointed,
turn on the
Scott, with
living room lights.
somebody speaking.
Oh, sorry.
Somebody confirmed that you see the sky site.
Yes.
I see
Yep.
it.
Thank you. Okay. So that's too bad. In let's look at tomorrow then. Maybe it's yeah. No, okay. We don't have great days. And it's really important to see all the question marks. It has a lot of doubts. But let's take, I hate this.
Let's
It
look
was
at
better
Thursday.
earlier. Okay, let's take this the best, as good as we can do. Okay.
We're flying Thursday. Let's
Um,
look at it.
let's look at Thursday. Okay. Not great, but let's look at Thursday. So the first thing I do is I turn on SkySight and I turn on potential flight distance. This is the most important thing because I've got to get an idea, and usually I kind of shrink it down. Got to get an idea of what is the general best area to fly. And if this is Monroe, the general best area to fly is here. Okay. And if I'm a beginner, novice cross countryer, the second thing I do is I put my wind barbs at, say, 4,000 feet, and it's showing 15 knots. Okay. So, as you know, I'm a firm believer that the first several cross countries one ever does, only you have to be cross countries, they should be up and down, ideally up the wind line so you can always get back. So the ideal cross country syllabus for you to start getting a feel for the air and how to follow energy lines is to go back up and come back, go into the wind, come back, go into the wind, come back. Tomorrow, of course, I don't like you to going downwind, but go to Appalachia Bluff, perhaps in the morning before you stop at Monroe, you drive over there, you walk that field. So it'll be a perfect thing to do Wednesday or Thursday morning. Start by walking Appalachia Bluff. Okay, this is serious. I'll give you the task for Thursday. The task for Thursday is go walk on the ground and discuss how you would land at Appalachia Bluff. And then do nothing but go over here, take a climb, come back. Take a climb, go over here, and come back. Go over here, come back. You're doing two things. You're getting confidence in your flight computer. Okay. In other words, once you're here, you got to come back with no stops to here and verify that whatever the computer said your arrival height was going to be in Monroe is indeed your arrival height. Because until you have confidence in your flight computer, you shouldn't be going cross country. Too dangerous. You need to have confidence that you're going to arrive where you need to arrive. So the only problem with this, as Steve will tell you, remember, Steve, that was your very first task, is to go up and down the wind line.
Yes, heading out to Taylor.
And so was Usher, John Usher. We walked the field. He did up and down wind line. And then we did a longer flight with a forced landing and a retrieve. And then he went and got his silver, his gold, and he won a day in the regionals, all as an 80-hour pilot. So if you follow the syllabus and you develop skills, then you can do cross country. So the skill I would recommend on a day like tomorrow, because nothing else is possible basically with this wind and this low, is up and down wind lining. Now, let's go a little more advanced and suppose you ignore forget the wind being that strong and everything else. So here's what you do is you do a point windigram, the next step. You can do a point skew too. Let's do a point forecast, okay? Point forecast for Monroe. It says that At 12:30, you can get to about 3,000 feet above the ground. Soarable height AGL is only 2,200. I mean, it's a terrible day, okay? Here's your soarable height with clouds, and it's saying that cirrus are going to obscure it, okay? Oh, what a shame that we don't have a better day to work with. The point windigram is super important. So we're going to do a point windigram for somewhere between Athens and, let's do a point windigram right here. All right. This is what the sky is going to look like. You launch at 1 o'clock, you got the best thermals. You're going to have low clouds. The wind is going to be about 10 knots. And then it's going to overdevelop a little bit, sink and come back. And then by 5 o'clock, it's going to die. And all because of these high cirrus up here. And then what's interesting is you can also look forward and pick your day. Okay, so this is Thursday. Too many clouds, too many high clouds. Friday is high clouds early, but then much higher, you get to 6,000 feet. And Saturday is a rip-roaring day, although the winds will be strong. The winds here are less. So this gives you their best guess. And remember, this is really likely to be wrong because this is 3, 4, and 5 days forward. But if you do it in the morning of the day you fly, it's going to be very accurate. Very, very accurate, okay? So you check this. So you selected your day, but let's say we selected Thursday. The next thing you want to do is do a route forecast. All right, now, before I do a route forecast, you start, again, as I said, with an overview of where to go, okay? Looks like if I were flying, I would go to Athens, and then I would go down here somewhere to Sebastian Cove and home. I mean, unless I wanted to go really far, but I'm not going to go to Paris. I mean, I could go to Paris with a tailwind, but I never make it back. So let's say you think that about this distance is all you want to handle, okay? Now, the important thing is how fast is it going to be in what direction? So now this is the potential flight distance if you flew all day long. If you launched at 11 and landed at 17, these are usually huge distances that are unrealistic. So you go to cross-country speed. All right, now here we go. At 13, oh, we need to launch early. At 13 on Thursday, you got good cross-country speed here, very good cross-country speeds. In fact, if we launch at noon, that was my mistake. We should have launched at 11:30, and we launched at 12:30 and didn't quite complete the task. At 12, you still can't climb, but you better be ready to go right at 1 o'clock because the atmosphere is going to pop. Okay, and if I'm here at Monroe, I could go to Winder or to Athens or to Madison. Any of those directions look good, but this is what I do. In function of the wind and the cross-country speed, I kind of plan my direction. So here's Monroe. If I went north, I'm going to get through some good stuff. If I go to Appalachia Bluff, and I'm doing pretty good. This, I want to be here. And at 1400, where do I want to be? Up. Oh, it's shutting down. I better be ready to start final glide back. At 1500, where do I want to be? At 1600. Oh, it recycled. So here's my idea. I go over here, and at 2 o'clock, I'm over here waiting for the overdevelopment to kill everything. So I'm over here in Athens, maybe fly down to Madison along the good air. And then after it cycles back, I come home. So you see, you get the idea how it works? By looking at cross-country speed, you can plan your flight directionally.
So you're finding
Joe,
it to be reliable, Fernando?
Pardon?
You're finding this to be reliable in your recent experience? Because I honestly have just kind of taken Lysite at face value.
It is very good directionally. The absolute numbers mean nothing, But if you say, okay, should I go east or west, north or south? This is very good. And how far should I go? And roughly, in other words, I asked the following question: where do I want to be early in the day? And where do I want to finish from? And then I
Okay.
decide my task to go where I want to go early, and I want to be in an area that I can finish from. Now, is it going to be stronger or weaker than this thing says? Yes. Forget the numbers. You're just looking at colors. Go to yellow and orange, young man. Stay away from blue and green. Simple as that.
But
And it's very good.
but to get the accuracy you're looking for, you have to look at by 9:30 the day of the flight, and then you got to take it at some face value. I think what Fernando's saying is looking at the difference in the colors is the best you're going to get out of it. Don't look at the empirical numbers as the givens. Look at the differences and the trends. That's I think where SkySight does a pretty good job of, but only that morning of was overnight's been known to change.
Yeah, the night before it's worthless. In fact, it usually comes out at between 9 o'clock and a.m., 8:30 and 9:30 a.m. And then it comes out again at 11:30. So I look at it on my phone and I modify. And sometimes between the 9:30 and the 11:30, there's a big difference, but the 11:30 is going to be spot on perfect.
Quick
So
question.
he's doing two runs in the morning now. But don't look at anything that doesn't say 8 a.m. or later or 7 a.m. or later. In other words, don't look at the 3 p.m., 3 a.m. or midnight sky side. You're wasting your time.
Quick question. Do you use the HRRR or the SkySight in the day off?
I'm keeping it simple for purposes of this. I usually look at a sky site, but if I'm serious, if I'm a contest meteorologist and advising task director, I look at 5 different models of 6, including the HRR. But just let me see. I don't even know. Let's look at HRR. Well, HRR doesn't go more than 18 hours forward, so it will not be available for Thursday. But Dieter, yeah, the day off, you can check the HRR too, if you want. But again, I'm not looking for accuracy. I'm looking for direction.
So
I don't bother with
consider
thermal strength and any of this.
Macro.
The cross-country speed resolves everything. It takes the wind into account, the thermal height, the thermal strength, and tells you where you are you going to be able to, go faster, which means you're going to have an easier time climbing and cruising. So don't even bother with thermal strength, height of thermal. You can if you want to be precise, but you're going to be disappointed because it's not going to be exactly right.
this is
So this is saying,
this is qualitative, not quantitative.
exactly, Harley. So then here's what I do. We're going to do a task. This is what I love about this, because from a strategy point of view, it's wonderful. So I done potential flight distance, just to kind of give me a feel for the day. It's a lousy day. But if I am going to do something, I'm going to start at launch at 12:30 if I can. Maybe it doesn't work. I'll be up at 13, and then I'm going to move east. And I'm going to move east, and then I'm going to go to Athens, and I'm going to go to Madison, fly the good sky, and then hope I can get home. Okay, which says I could. Okay, so the task is very obvious. It's going to be a triangle, boom, boom, boom. Okay, so let's do it. Okay, cross country speed or potential, doesn't matter what you have in the background. Let's leave potential flight speed in the background. And then you go to here where it says you have to load the waypoints. You just load the Cordeal flight if we're there on Monroe. And then we come up here. So we've already looked at the point forecast. We'll look at the windigram. Now we go to the route forecast. And we're going to click and make a route. We're going to do Monroe, this Athens, Madison, and home. And it's a 66-mile triangle, which is 100K, and I'm going to save it. Now, you know what is really cool? Now, up here, there's a little glider that is flying the task and it's predicting what you're going to encounter. So right now I have it set. Notice that these speeds are pretty, it depends. But it says that if you start at 1, you're going to end at 1420 for an average speed of 79. If you start at noon, you're going to go really slow. And then you can scroll down and say, okay, what time can I start to give you the most speed? Well, 1330 seems to be the optimum time. It's 79 miles an hour. If you start at 14, you're going to get hit by that cycle down and you're going to be slow. And then if you wait till 3 o'clock, it's going to cycle up again. And if you believe light sight, maybe you start at 3:30 and land at 5. So take a pick. But I'm going to take my pick of this flight right here. I click there, and here's my height band. Now notice down here in the screen, you can all see the glider moving against the map, and I'm just notice how beautifully I am. You all see the little glider flying?
Yes.
Yeah. And you see the deviation is saying for me to go a little bit north towards Appalachian Bluff. And notice I'm still in good air. And then I just escaped the bad stuff. If I got out of here at 1330, I got to Athens, boom. Now I'm turning Athens, and notice the soarable height is 3,530 feet, 4-knot climb at 1353. It's giving my predictions and my budget. Okay, here I am. I'm coming in good air, good air, good air. This is the best part of the day right here. This is the optimum. I'm at 4,190 feet, but the day is overdeveloping a little bit. Too many clouds. You see how the clouds are thick up here on top? Do you see the profile? Clouds have thickened up too much, so they start to weaken. And now I got to take a really good climb and just drift home. Take any climb I get, make it home. Boom. And if I do, all goes according to plan, I'm going to land at 16, whatever time this is. Strategy B, let's go to strategy B. I'm going to wait later. Let me see if I can do that strategy. Start. How does it work? Custom. I'm going to start at 1530. Okay, let's see how that one works. Here I go. Good air to Athens. Not quite as strong as before, but a more consistent return home. It's way too risky though, because this could really shut down. Oh, then it shuts down, but you're on final glide, so you don't care. Okay, so you can see how wonderful this is as a planning tool. And why I completely advocate now only do tasks in the morning of using this. You can also see very cool things, like, for example, you can do the queue overview. It's going to show you where the queues are, lots of queues, too many queues, actually. These little dots of queues and how high they are. And then as time wears on, let's go back to noon. Very few queues, very low. And you see this dark shadow here? That's the problem. Those are cirrus. Oh, then the cirrus come in really thick from the west, a band of cirrus coming in. And the queues die over here, as you can see. They kind of resurge on the backside, etc. So, and then let's say that I want to do the task planning. Once I do it here, you may or may not want to do it in CU, but this is then what I would recommend. CU can also load this is a specific task that I would recommend potentially on Thursday. This is when it was a little bit better. You can load SkySight on CU, okay? So then I'm going to do a task. Let me do a new task. Let's see how to do a new task. I forgot. Can you all see this screen, the CU screen or no?
No, we
Probably
still
not.
see
Yeah.
sky sight.
We still see
We're
sky
still
side.
in sky
Sky
sight?
sight. Yeah.
Okay, sorry. Stop share. Share. See you. Share. Okay, somebody tell me when they see sky sights.
We see you.
Yes.
See you,
We see
sorry, see
you.
you, perfect.
This is see.
Okay,
Yeah.
so we're gonna add a task, new task. Okay. And what you see in the background is potential flight distance. I marked here standard class, potential flight distance. Somehow the wind flags are not showing potential flight distance. Okay. So I go like this. Take off from Monroe. Let me zoom in. Okay, take off from Monroe to Athens, to Madison, to Monroe. Now, here's the real important part, okay? You don't really want to start newbies doing this. What you want newbies to do to have success is do the following. Okay, escape. That's the base task. But here's what you do. Is you double click and you say task properties. Okay. There's a task. Monroe, Athens, Madison, Monroe. But you don't want it to be a racing task. That's too hard. You make it an assigned area task. If you guys get close enough, you've done it. And then you go like this. Start Monroe, instead of a traditional, pie slice, you say, no, let's make it a whole circle, 180 degrees. And let's give you 2 whole miles to start. Okay. In Athens, that's kind of scary going over there. So just the goal for the newbie is going to be to get within 10 miles of Athens. And the goal for Madison will be to get 180 degrees within 10 miles, or let's call it 8 miles of there. And then you're going to finish 2 miles from Monroe, so you got time to enter the pad and do things. If you get within 2 miles, you consider to finish. You don't have to cross the line right over the airport, the old-fashioned way. Okay. Oh, now look how beautiful this is. The nominal distance is 66 miles. But if you were to go all the way to the back of that circle and all the way to the back of this circle and all the way, you would have flown 99 miles. Or you had a successful completion if you start here, nick here, and come home. Okay. Now, the real beauty of this is, let's say that the wind was going and the cloud street was spectacular. Instead of, you got plenty of nicking here, but you got free distance. You can fly another 5 miles without losing a foot on a cloud street. You go. Come back along that cloud street, like we said. You didn't lose a foot. You gained 5 more miles. Then you start going over here and you say, oh, wait a minute. It looks better on this side. So you deviate, and make the turn point right here. And then you keep coming until the cloud streets align up there. Boom, take it home. It's so much more fun and easier to do this kind of cross country because you learn how to follow energy lines, because you can go here or here or here. You say, okay, so what I do is when I start, this is a real actual racing strategy. And I got a circle. I say, do I like the middle, the north, or the south, southern sector? I say, I'm going to go north. So I start deviating all the way from here. And I line up. The wind might have been this way, and I don't want to fly slightly crosswind. So I go to here, boom, turn there. And now I'm crosswind, but there's more heat to this side. So I go, let me take the picture right here, which is the highest energy point. And then I find a street to come home, and I go, here. So it gives you the freedom. You get to practice wind line following. You get to practice cloud streets without bothering to have to go to an exact point. And if you chicken out or the day turns out good, you can still get a success by turning here. Okay. How do y'all like that?
Um,
Joe.
I'm just gonna ask our newbies, Eb and Terry and Thomas, do you understand what he did there and what the difference is between those angles that he put in and the circles?
Yes.
Okay, that's a yes from Thomas. How about Terry?
I'm not sure I do exactly. I mean, like, aren't I underflying the distance if I only nick the circle and follow the energy?
Well, and it's the difference between the tasks, and that's why I'm asking. Let me ask Ed and Eb, and we'll go back to that. Eb, what do you think?
I'd have to play with it, frankly.
Okay, well, let's
Yeah.
play with it here for just 2 seconds. All right, so right now, if you were to fly directly from Monroe, which you can't see my cursor, but you can see the dot there in the center of the big circle. Then you see Athens. Yeah, thank you, and then Madison. What we would normally do back before all this fancy GPS stuff is that you'd have to go take pictures of those. So you would generally have to go around the backside of Athens and then around the backside of Madison, and then return home and go through a start point that's sitting there right over Monroe. And that would be that nominal distance that he pointed out, 66.2 miles. That would be a flat 66.2 mile
The blue
triangle.
lines. Yeah.
Exactly, the blue lines, flying the blue lines. All right. So what he's shown you is what we would call a turn area task. And what they do, and this is even better for like the sports class. When there's a disparity of performance in aircraft, like in the sports class racing, where you've got, an old jalopy like sorry, Chip, the LaBelle. He's not here, but I'll say it anyway. And then, oh well, I can say that for Dennis. And then Fernando, who could fly as JS1, and Mitch is ASW 27, and then Thomas, you could fly Whiskey Whiskey. So with that disparity in performance, you leave Monroe, and this your task won't start until you leave the circle. So if you wanted a nominal distance, you would exit. It would show me a tangent line at the edge there, Fernando, on that. So you know what I'm
Identify
talking
the
about.
minimum distance.
No, not the minimum. You would want to
Oh,
leave like a tangent or the minimum distance. Yeah, you can do that. So you
okay.
would
Do you want
start
the start to be at the edge, right? Let me
right.
do the start at the edge and the finish at the edge. So
Okay,
I'm
go
just
ahead.
doing some technical things
Yeah,
here.
go ahead
Just a
and
second.
fix
Okay.
that real quick, and that'll
Let me
make it
fix
easier
that.
for these
Move
guys.
origin and reduce leg distance. See, I moved the actual start from here to here.
Right, perfect. That's
And the finish,
exactly what I wanted to explain to
and
them.
the finish is actually you're going to finish here, and then you can take your time doing your pattern. But the
Perfect,
speed is
perfect.
only
I
going to
didn't know.
count
See, you did
from
that.
here to here.
Yeah. Okay. So let's show that in the picture. So what you'll be able to
Now
do,
it's 62 miles. You see, we
right?
saved 2 miles on the start and 2 miles on the finish.
Right,
And
and you can
then
reduce. Go ahead.
let's suppose that you're flying a slow plane, like Joe mentioned, and you don't want to go as far as 66 miles is too long. Uh, so you plan your flight. No, I can't move the point. That moves the whole task. But you don't have to go to here like we used in the old days. You can go here. Anywhere in here, the computer, the latest scores, and analyzes your flight is going to know if you go to about here is the farthest point you achieve in their turn, it will mark that as your achieved distance. And then you turn here, it will mark this as your achieved distance. So your task is going to be from here to there, wherever is the farthest point you achieve, to this point, to that point. So you're free to go anywhere in that zone and be scored as to exactly where you decided to make your turn. In other
Okay.
words, instead
So
of being a tiny turn point, we have a gigantic turn point.
right.
And then we have
Now,
So
another
what
gigantic turn point.
essentially what will happen says we're only looking at at lines drawn in this page. When we have an actual trace, we'll get to see that at camp. When there's an actual trace, the software that we have both in CU and in OLC, and then of course WeGlide will optimize that. It'll follow your trace, and it'll draw those lines inside your trace to optimize the distance that you have flown. And I'll explain that all at camp. We'll have or maybe I can do that next Thursday when we're talking about that.
Yeah. And Joe, the point that we're trying to make here is learning cross-country skills. I'm not even talking about scoring or traces or distance. All I'm saying is break the paradigm that your cross-country must be to a declared point. Just free fly. The first free flights we talked about are just going to be up and down the wind line, up and down the wind line, up and down the wind line. And then when you say, okay, I'm going to go a little bit farther, this is the task you're going to do on a day, especially when the wind is from the south. Let me give you a new task. When I add a task, this is what I recommend. Boom. Sorry.
But while you're doing that, let me add one point of clarity here for people who don't totally understand. These are racing techniques for people who want to get started in racing. This does not apply to badge tasks. Okay. And there are such records called free distance where you could do this and you would get a state record if you achieve it. But for badge tasks, you will fly to a specific point.
Right.
Good point, Harley. And my point is, before you try to fly badge tasks, you got to learn to fly cross country, basic cross country. I'm talking about is to develop base cross country, don't try to fly a badge task.
Yeah, absolutely.
Fly free distance, but with kind of an objective.
Yep.
Yeah, and this is actually covered in Tony Smolder's his SSA cross country camp. This is exactly the point that he's making with the syllabus that he's provided. Hartley, have you had a chance to look at that,
no, I haven't, but I will certainly.
Please do. And what about Scott? Are you there still, Scott? Scott, have you had an opportunity? He's not there.
Okay, look at this task I just put. This is the actual one I recommend that you practice with. Up and down the wind line. And in fact, the one I really would recommend, I'm going to get radical on you guys, on Thursday, is this task right here. Oops. And let me adjust. This is what I would do on Thursday if I were out there and trying to learn.
Where'd you drop that off? There you go.
Okay, I'm just going to go there. All right. Okay. This is the actual task that Steve did when he was learning to go cross country. And I'm going to show you the syllabus. What you do is you start, first of all, you drive to Sunset Strip in the morning. You walk it. You look at Google Photos. You study the heck out of it. You know exactly if you have to land there, but you won't have to land there because of the way I'm going to lay this out for you. Then you start. You go upwind until you have enough to make Monroe plus 1,500 feet to spare. Then you come back. Then you practice your thermaling skills. Then you go again and come back. Chicken out, come back. Climb again. You're going to get a lot of thermaling practice. And each time you go a little bit farther because you're going to get better at finding the wind line. And then at some point you decide, okay, I'm going to climb again. And rather than chickening, I'm going to climb, actually go to Sunset with enough altitude to plenty arrive there and find a thermal there. And if I don't, I'm going to land there because I know how to land there. Then you find a thermal somewhere in here and come home.
You're not going to land there, Fernando, because it's a subdivision.
Yeah.
It's a subdivision. Okay, it doesn't
It's a
exist.
subdivision.
Let's do Alcovy then. Is that landable?
Yeah, I've been to Alcovy. Yeah, very landable. Yeah.
Okay, do that one then. It's not exactly on the wind, but you get the idea. And let me actually show the syllabus. But this is how you start going cross country. It's not by doing badges, it's not by doing tasks. It's by learning to fly up and down wind line, and then by learning to fly big area tasks with little triangles. Okay. This is what we've got to have, this mindset that is different from the traditional mindset that you go through a badge program. Badges are too scary. You know, if you don't know how to thermal well, you don't know how to find a glide back, you don't know how to find places to land, you don't know, that's too scary. So we're trying to, this whole program of cross-country instruction is giving stepping stones. Let me give you the actual syllabus. I don't know if, I guess the screen hadn't changed. So let me stop share. And this will be the final thing to conclude today's presentation. Do you all see the screen?
See you.
No.
Nothing yet.
Nothing yet. God, I hate this
Press
thing.
share.
Let's press share. I got to go to Zoom. Then I got to press share. Then I got to go find the slide. And then I got to share it. Okay. You all see something that says fundamental processes?
Yep.
Yes.
Yes.
Fantastic. Do you still see it?
Yep.
Yeah.
Okay. You know, Coach Nick Saban says it's all about the process. And in the firm that I grew up in, it was an industrial engineering consulting firm, and we developed very advanced methods of training, you know, industrial operators. And it's all about breaking the task into sub skills and then teaching people how to perform each thing to perfection. And then they put it all together and they do the whole job. There are only 6 things you got to know to perfection to fly cross country. And as Steve Wisniewski, John Usher, and other people that have gone through this process with me, the first thing you have to do is you have to pledge, raise your hand and pledge in front of everybody that you never will release from tow above 2,000 feet. There's all kinds of reasons for that. But, you know, Ebb and Terry and so on, you don't have to take that pledge yet. But one skill you're going to have to develop is how to climb from 2,000 feet or less. I mean, you just got to know how to do that. And that's why I say don't spend time thermally high. Come down below 2,000 and climb again. Come down below 2,000, climb again. Come down below 2,000. I mean, any time you spend climbing above 3,000 feet is completely wasted time. In other words, all you're doing is trying to stay up in the air. Your goal should be to develop a skill, not to stay up. Get your head straight. Okay, your skill is I'm going to learn how to climb from 1,500 feet or 2,000 feet. Got it? Pledge yourself to that.
Yep.
The second thing you have to learn is how to enter the thermal and leave the thermal at the correct height. When you're going cross country, the last 200-300 feet are really slow up there, and the wind is blowing you backwards, and you're wasting your time. So when the rate of climb kind of comes down to about half of what you've been achieving. So let's say you've been averaging 3, and now you're up there getting close to the cloud, and you're only 1.5. Well, go ahead and leave. Go to the next cloud. Don't waste your time. And how to enter, you know, you got to enter at a comfortable high altitude, and probably when you're down 1/3 of the way. So if you start at 5,000 feet or 6,000 feet, when you're down to 4,000, you better be on the next thermal. So you're going to be flying between 4 and 6 or between 3,500 and 5,500. Maintain correct cruising speed. What are the 3 speeds for a 21? Anybody?
5.
45, 55, 65.
Thank you, Tom. You know, on a discus, they would be 45, 65, and 80 on a dry discus. You cruise at 80, you bubble through at 65, and you climb at 45. So just remember your 3 speeds. It's surprisingly hard to maintain the correct cruising speed. As soon as you start, feeling like you're a little bit low, you start slowing down.
Now,
Then
one
the
one
two
quick question. Sorry if I could, one quick question about too, Fernando. When you're talking about setting those first couple smaller cross country tasks to go kind of from point A to point B and working the energy lines back and forth, and trusting that glide computer. What kind of value are you using the glide computer versus for like a McCready value versus what speed you're flying?
four
Four.
McCready,
Okay.
which is super conservative.
Okay.
4 McCready. Start with 4.
That's what I've
That's
been
what
Perfect.
we all use in racing too.
I've been
Okay.
using. I haven't gotten in trouble yet. Knock on wood.
So you're flying a 4 McCready value for a glide computer, and then your actual speed's probably more of like a 3-ish. So you kind of have that little bit of a safety margin there.
I pretty much.
Exactly. I have, in fact, the LX cheats already automatically for you. I have 1,000-foot safety height, so it programs me to arrive 1,000 feet above wherever I'm going. And I have 1 knot safety McCready. So if I dial 4, you'll tell me to fly 3, you know, and
Okay.
even though it's calculating at 4. But you can just do it manually. Just put 4 and then slow down 10 knots or whatever it is, and cheat. Um, but you have to have absolute confidence in your final glide. I mean, my final glide computer is so perfectly tuned. I leave with 200-foot errors from 20 miles, and I don't lose 200 feet. I mean, it's perfect. It's perfect. Of course, I know how to fly energy lines, which helps. But so you're going to learn how to fly energy lines, select fields, and execute final glide. So this is your homework. Imagine you're a test pilot, and this is the maneuvers you got to execute. Okay, you got to execute this. You take this in the cockpit with you, and you're going to check. First thing is you're going to release at 2,000 feet, and your first climb is going to be to 3,000 foot max. Okay. Release at 2, climb to 3. Even though there's 4 and 5 available, that's not the job. The mission today is 3,000 max. Then you exit upwind, exactly upwind. Now you can deviate a little bit and use the clouds to the best of your ability, as long as you're following the clouds, which will be aligned with the wind. And you fly straight meaning, within reasons, snake into the clouds until you're at 2,500 feet. So you lost 500 feet. Then you U-turn, you look down, you look at the landing fields, and you come back home. Okay, watching fields. You're guaranteed to make it home at 2,000 feet, because if you lost 500 going upwind, you're going to need less than 500 going downwind. Okay, so this is a very safe thing to do. You release at 2, climb to 3, fly 2,500 feet, which will be only about 4 or 5 miles. If you're good, if there are clouds helping, or maybe you only go 2 miles and you lose 500 feet in 2 miles. That would suck, but it could happen. But if you exit that thermal upwind, there's going to be a continuity. It's going to be like a cigar. There'll be other thermals on that exact line. If you fly at 45 degrees, you're going to be on the sink line, and then you lose. But if you thermal, and then you see the drift of the thermal and follow that wind line, there'll be another thermal, another thermal, another thermal. So you might be able to go 4 or 5 miles. For example, on that flight, which is going to be a state record, I think I submitted my flight last Monday. I left home, I started the task, and I flew 55 miles and lost 800 feet without turning. 55 miles, lost 800 feet. I can show you all the trace by flying the wind line towards Perry. And so then as you come home, you observe the landing fields in your home. Then you repeat it twice. So the second time, instead of going to 3,000, you go to 3,500, and then you return to arrive home at 1,500 feet rather than 2,000. Okay? And you check your computer. In other words, you go as far as you can, such that if you make a U-turn, your computer's saying from here, you're going to arrive home at 1,500 feet above the field. Do it again, do it again. Then you're ready for the big move. You climb as high as you can. Hopefully you're doing this on a 4, 5, 6,000 foot day. And you run upwind all the way. until you're 2,000 feet above glide home. By that time, you should have a lot of confidence that when it says 2,000, it's 2,000. Then, when you get to that point, you run upwind, you look down and you select a field and mark a field, memorize it, and you scout it from the air. Now, you found the field at 2,000 feet or near, and then you fly around it a couple of times until you're down to 1,500 feet above glide home. Okay, so it's totally safe. You're always going to make it home. You're going to do this 3 or 4 times. You're going to be, and then the big day. You climb at that field and either return home or make a jump to the next upwind paved airport if there is one, and you get there 1,500 feet above. When you get there, 1,500 at paved airport, you either land there because you prearranged with somebody to pick you up, which normally was what I would recommend, or you return home via your marked intermediate field. And you're going to either land there or find the climb to go all the way home and then fly without stopping the entire flight home. When you get home, you execute a low save or land at home, repeat above, blah, blah, blah. Then you drive to the marked field and evaluate, send your flight log to Harley and Fernando, and call us for a debrief. That's the homework. How does that sound, guys?
Sounds doable.
Hey, Fernando, I'd like to state the obvious just to make sure it's perfectly understood. When you're saying 1,500 above return field, that's when the safety altitude on your flight computer is saying that you would return home and arrive at 1,500 feet, right?
Let's decide that. I hadn't thought about too much. I would say above the ground, which is
I'm
1,500
sorry.
feet of
That's
safety
right.
altitude.
Yeah, that's
Is that what you understood, Steve, or no?
You would arrive 1,500 feet above the runway.
Above the runway, so you still have 500 feet to enter the pattern.
Yep.
Now, the first time you do it, you arrive 2,000 above the runway. You know, and the second time you arrive 2,000, and then by that time you got your glide computer so well tuned, you're willing to go as low as 15. But whatever your safety margin is. Now, Steve, describe to everybody your experiences doing this task, because you're the pioneer. You invented this task, and how you went, how much farther you went each time going
Well,
upwind.
you invented it, but I followed it. So the day we did that, I think it was right before we went down to Seminole 2 years ago. It was a east or southeast wind, and you pointed me at Taylor. And so the first couple times I went out, I was very tentative. The lift wasn't terribly strong, and I wasn't doing a great job finding wind lines. And I was thinking, I'm going out a couple miles, going out a couple more miles, but it's way over there. I'm never going to get there. And I don't remember if it was like the third or fourth time, but I finally found that thermal that got me up a little further, and I was able to push on. And
Taylor is like 12 miles away, right? Or not that far?
order of magnitude
Maybe
10,
8.
probably.
It's about 7 miles.
7.
7.
Taylor?
Yeah.
Really? Is that all?
Yeah, but it feels
Yeah.
like a long way.
Yeah.
Like it felt,
When you do,
I've
it felt like a lot more.
felt like a lot.
I've been there. I can tell exactly how far away it is.
Well, in any case, it was not a super high day, and it was a blue day. So
Thanks, Hartley.
I didn't have clouds to guide my way, so I was looking for those blue thermals. But yeah, I mean,
not strong and with good wind.
yeah, it was probably about 10 or 12 knot type wind. But you just build the confidence as you push on. And the thing that I still do, and I really need to knock this out of me, is there's a huge difference between upwind and downwind. I mean, you feel like you're getting low going upwind and you're never going to make it back, and then you end up over the fields 1,000, 2,000 feet higher than you thought you were going to be. So that's something I'm still trying to knock out of myself.
Yeah. So then,
guys, I need to exit. My dog is.
Yeah, we got to wrap up.
Yeah.
But anyway, so just to summarize, you got to thermal better, and you got to take baby steps on your cross country. And we talked about how to thermal better and the exercises, and we gave you all kinds of ideas how to do baby steps, assisted by SkySight to Plan. Harley, you want to give us a little wrap or summation or whatever? Senior person, final words.
Yeah. Basically, what you've all heard some basic stuff, some advanced stuff, some stuff that you've never even thought about if you're new to this. Um, Gives you an idea of that a glider is more than just something that takes off and lands at the airport. What has been outlined here is a progressive method of practice that builds ability and confidence. And some of the more cross-country stuff, going out and waiting for 1,500 feet above final glide and all that, requires that you have confidence in your own flying of the plane and confidence in the instrumentation that you're using. So you must know what it's telling you and how to use it before you start using it in anger. Practice, practice, practice. Basic. There's two true basics. You can cruise inefficiently and still get there for many enjoyable tasks, but you cannot be comfortable doing this stuff if you can't thermal. So thermaling is the essence, the essential skill. And this is what you practice. And as Fernando said, and as many books say, don't just sit there in one thermal all day and say, I lasted longer than you. You know, go away. if you have to land, okay, so you land, you know. And I'll just add one other thing. This information has to be ingrained by a lot of repetition and a lot of introspective thought. So for those who do not own it, immediately order G. Dale's first book, The Soaring Engine. It will explain a lot of this stuff, and you can read it over and over and absorb it bit by bit. So that's my takeaway. Thanks, Fernando. This is really
Tell me
good.
the name again of the book.
G. Dale, The Soaring Engine. It's available through, I think Wings and Wheels has it, and I think Cumulus Soaring may have it.
Right.
Volume one, I think, is the thermal one.
Volume one. There's 4 volumes. Yeah. All 4 are I have all 4. When it arrives, you will think that you have been robbed, because it's a little paperback book about the size of Reader's Digest, a little bit bigger, and it's like $45 or something like that. And you say, "Holy shit, I have been screwed." But when you open it and you will read it, you'll realize that you would have paid $100 for it.
Right. Thanks a lot.
So do that. That's about all I have to say. Thanks, Fernando. This is really
Thanks,
good.
Fernando.
It rambled a bit, but that's what we need, and that's what we enjoy.
And thank you, Joe, for pausing and resetting some points and making sure that everybody took it at their own levels. I appreciate that, Joe.
Yep.
All right. So.
All right, man.
All right.
Thank you.
Good night, everybody.
Hartley, can I ask you a quick question?
Yeah, shoot.
Not for the rest of the group. It's something just on my ship. My clear nav when I was down in Florida, my USB port, I was having trouble getting my USB key to actually be recognized. Do you know where I can get one of those replacement USB port? What kind of cable that is? I might not make it to the airport before Cordeal.
It's just a regular USB male on one, USB A.
Oh, really?
End and female on the other.
Oh, it's just a generic USB.
Yeah.
Male. Oh, okay. Cool.
Okay.
All right.
Are you trying to plug it to the back of the clear nav or an extension from the clear nav to a panel slot?
Yeah, right now I've got an extension to my panel, and the last couple of days I was at Florida. The first day was intermittent, and the last day I just couldn't get it to work, and I need to deal with that.
Don't let me belabor the obvious, but have you reached in behind and make sure it's plugged all the way in? Those connections tend to wiggle out after a while.
I'll check that. I haven't been out there since I got back from Florida. So
but, I mean, it's just a plain old ordinary USB extension.
I've got a couple of those. So okay, good. All right, thank you.
Okay.
That was all. I just want to make sure I got what I need before Cordial. So
Yeah. All right.
appreciate it.
Everybody else? I'm going to stop the recording.
Yeah.